a weekly online lecture series, an engineer's talk being organized by Institution of Engineers India Salem Local Center in commemoration of its 30th anniversary celebrations. I would like to invite now the chairman, IEI Salem Local Center, to welcome the guests on the gathering. Please, sir.
Yes, sir. Thank you, sir. Good evening, good evening to all present for this session. It gives me immense pleasure to extend a warm welcome to each one of you on behalf of the Institution of Engineers India Salem Local Center, as we proudly celebrate our 30th anniversary year through the 102nd special webinar, as Arun sir mentioned in our ongoing Engineers Talk series. It's a knowledge sharing platform that has now become a hallmark of continuous learning and professional excellence. At the outset, I take great pleasure in extending my warm greetings and heartfelt welcome to our today's chief guest and keynote speaker, Dr. Sriparna Shaha ma'am, Associate Professor, Department of Computer Science and Engineering, Indian Institute of Technology, Patna, Bihar. Actually, ma'am is one of India's most distinguished researcher in the field of AI, natural language processing, and deep learning. Ma'am has authored over 450 research papers, holds an H index of 51, and has a total of 13,479 citations as per Google's Scholar. Actually, ma'am's remarkable academic journey and global recognition truly make her a role model for aspiring researchers and professionals in the computing domain. We are indeed privileged and honored, ma'am, to have you with us this evening to enlightening us on the fascinating topic, charting new territories, multimodal information processing in NLP through deep learning and language modeling. I am also take this opportunity to extend my warm welcome to our beloved Honorary Secretary, Dr. C. Dhaumni ma'am, our respected council members, past chairmen, past secretaries, and committee members of our IEI Salem Local Center, eminent fellows, senior members, corporate members, institution members of IEI across Salem, faculty members, researchers, students joining us from various, again, academic institutions. And of course, our honorary secretary and dedicated technical team and organizing committee members whose efforts have made this session possible. Also, we want to thank Engineer T. Thiago and Armam sir for these again possibilities. So, and a very special note of appreciation goes to our Engineers Talk participants. Your consistent presence and engagement over 101 consecutive weeks have been the driving force behind the success of this series. This evening's topics is particularly inspiring as it explores the convergence of language, vision, and AI, a frontier that is shaping the next era of human-computer interaction and intelligent system. With Dr. Sriparna Shaha ma'am's deep expertise and vast research contributions, I'm sure today's session will provide us with again rich insights into the evolving landscape of multimodal information processing and deep language models. Before concluding, let me once again express my heartfelt gratitude to our today's chief guest and resource person, Dr. Sriparna Shaha ma'am, for graciously accepting our invitation amidst her busy academic and research schedules, and to all the distinguished participants to joining us this evening. Let us now look forward to an inspiring and intellectually rewarding session. Thank you. Jai Hind.
Yeah. So, sir, is my screen visible?
Thank you. Thank you, yes, madam, and thank you very much, sir, for welcoming the guests in the gathering. And now it's my pleasure to introduce Dr. Sriparna Shaha, Associate Professor, Department of Computer Science and Engineering, Indian Institute of Technology, Patna, Bihar, India. Dr. Sriparna Shaha received the MTech and PhD degrees in Computer Science from Indian Statistical Institute, Kolkata, India in 2005 and 2011, respectively. She has authored and co-authored more than 450 papers. Her current research interests include natural language processing, machine learning, deep learning, multi-objective optimization, and biomedical information extraction. She is also authored a book published by Springer Verlag. Her H index is 51 and total citation count of her papers is 13,479. She is also a senior member of IEEE, ACM, fellow of IEI UK, IET UK, IET. She is a recipient of Lieutenant Rashi Roy Memorial Gold Medal from the Indian Statistical Institute for Outstanding Performance in MTech. She is a recipient of Google India Women in Engineering Award 2008, INSA Young Associate in the year 2024, INSA Distinguished Lecture Fellow in 2025, NASI Young Scientist Platinum Jubilee Award in 2016, and many more to her credentials. She is the recipient of Fulbright Nehru Academic and Professional Excellence Fellowship in 2025, Humboldt Research Fellowship, Indo-US Fellowship for Women in STEM in the year 2018. She is currently associate editor of several prestigious journals like IEEE Transactions on Computational Social Systems and in many more journals. Her name is included in the list of top 2% of scientists of their main subfield discipline, artificial intelligence and image processing, across those who have published at least 5 papers for consecutive of 6 years. And she has even more credential to mention. And with these words of introduction, I would like to invite Dr. Sribarna Saha to present on the topic charting new territories, multimodal information processing in NLP through deep learning and language modeling. Please, madam, over to you now.
Yeah, so thank you very much for inviting me as a speaker in this occasion. Many thanks for the invitation. So I hope I am audible and my screen is visible.
Yes, ma'am.
audible.
Yeah, yes. So today I just would like to discuss briefly about my current research areas. So this is basically multimodal information processing. In IIT Patna, we have a research team and my PhD students are currently exploring different areas of natural language processing, but there is one commonality. They all are dealing with the multimodal inputs. Like we are not only dealing with the text data, but also image and the video data. So through my talk, I will showcase you several instances how the multimodal information can enhance several NLP tasks. So let me introduce like what is the multimodality. So basically, our experience of the world is kind of a multimodal in nature because we have multiple sensors in our body. Like we can hear the sound, like we can, whenever suppose there is an object and we have to take the decision about the object, we used to utilize our multiple sensors. We used to see the object, we used to hear the sound of the object, we used to feel the texture of the object, smell the odors of the object, taste the flavors of the object. By utilizing the multiple sensors, by collecting the information from the multiple sensors, we used to come up to a decision. So multimodal learning or the multimodal information processing means that how to collect information from multiple sources, and then can we take a decision about a particular object or about a particular instance. So basically, in case of natural language processing, here in our real life, you know that for example in social media or in news domain, we are having multiple sources of information. We have the text data, we have the image or the video data. So we are having multiple sources of information, and this is basically called the multimodal information processing. So let me show you with an example. So basically, another important aspect of multimodal, why we need multiple sources of information, is that the text and the image are complementary to each other. Like abstract concept, freedom, gravity, etc. This can be better described using text. Uh, data. So in natural language processing, there are many tasks, like for example, and given the scenario to speak a particular problem, a particular topic speaker. Two speakers are speaking, Joey and they are basically discussing on a particular movie, and maybe the first one is asking you, and one is saying, oh yeah, which part exactly? The kangaroo. So this way they about moving, and we need to understand what is. So you can see that here we are not only relying on the textual part, like after seeing the textual utterance and the audio tone and the facial expression, we can better understand the emotional state of the speaker. Similarly, in the right hand side, we can see some chord. Maybe there is a flooding situation. Then the during the disaster situation, the physical characters that people use media. Two categories. And then all the informative posts can be summarized, and the summary can be given to the rescue team, and the rescue team can plan for the rescue operation. And nowadays, whenever someone is posting something in the social media, we not only write the text description of the event, but we also upload the relevant time of the event, or a kind of a multimodal information. We have textual description, we have relevant images, and also we have sometimes a video description of the event. So my students are working on multimodal information processing, and they are applying the multimodal information processing in various domains. For example, we are building some chatbot. Chatbots are very common nowadays in the different domains. All the customer care representatives are now replaced by the chatbot. Whenever we are calling Make My Trip or any kind of Make My Trip or any kind of customer care representatives, initially we need to talk with the basically a chatbot only. So we are developing some in-house chatbot, and here also we are using the multimodal signals. Like the chatbot, when the chatbot is chatting with the user, the chatbot is not only relying on the user's textual input, but also users, the facial expressions or the audio tone, and then only the chatbot can easily understand what is the what the user is trying to say, what is the user's communicative intention. That way, that basically the chatbot can easily understand after getting the audio tone or the facial expression and the textual signals. So we developed the chatbot in various domains. In the healthcare domain, we basically developed basically a chatbot which is helping the doctors in the preliminary symptom investigations. Now in India, given the population, doctors are overloaded, and doctors do not have time to in a big hospital. The senior doctors, they do not have time to see all the patients. So to reduce the doctor's time, can we have a bot which can do the preliminary symptom investigations, and they can basically prepare a report, and that report can be seen by the senior doctor, and they can simply prepare the report. So basically, this way we are developing some virtual doctor. And one of my student has also started his entrepreneurship journey by the development of this virtual doctor. And he has developed this clinical assistant, a company called the clinical assistant. And he is one of the 10 best Prime Minister Research Fellows selected all over India. And then we also developed some chatbot for the mental health patients. There are many students who are suffering from depression, anxiety, bipolar disorder, etc. And when a student is suffering from this kind of mental health diseases, because of our stigma, generally they do not want to meet with any kind of psychiatrist, or they refuse to take any psychiatrist help. So can we develop a bot? But they just really just want to discuss regarding their problem with a friend. So basically, we developed a bot who can simply act as a friend, and we with this app they can simply discuss about their problem, and the bot will simply generate some positive, sympathetic, and empathetic, positive motivational responses. So our motto is not to replace the psychiatrist, but only to generate some motivational and empathetic responses, just to boost the morally of the student or the patient who is suffering from the mental disorder. Then we also worked on the complaint mining. So complaint mining means that suppose a user is having like we are purchasing nowadays products online from Flipkart or Amazon. We are purchasing several products, and whenever we are not, there is a suppose damaged product, or we are not happy with the product, then we used to write the reviews about the product in the online platform. And many of these reviews are complaining in nature. So basically company like Amazon or Flipkart, they used to receive many complaints per day. So they are interested in developing a automated system which can scan through all the reviews, and they want to categorize the reviews into complaint and non-complaint. And if suppose a review contains some complaint, and whenever we are writing the reviews, we are not only writing the textual review, but also we are uploading the image of the damaged product. So this way, this is also multimodal in nature. And initially we worked on the binary classification. So given a review, we only have to classify whether this is complaining in nature or this is non-complaint. But later on, we also go deep into this. Like if suppose there is a review which is complaining in nature, so the person is complaining on which aspect of the product. Like the product may have many aspects, like a mobile phone has many aspects like the camera quality, battery life, the color, or the screen size. So on which aspect the person is complaining. Maybe the person is happy with the camera quality, but the person is complaining about the battery life. So on which aspect, this is called the aspect-based complaint mining. So we want to understand on which aspect the person is complaining. And you know that this era is basically on explainable AI. So maybe only the classification is not enough. We also need to explain the decision about the classification framework. So we were highlighting the reason of like the important words from the reviews, which are helping us in taking a decision that why this is a complaining review. So these are all our works related to complaint mining. Then multimodality is also applied in bully detection. You know that often women and children are often bullied in social media. So there are many memes which are being targeted towards women and children. And these memes are collections of text and images. So basically, again, this is a multimodality because we have to understand the image, we have to understand the text, and by analyzing the text and image both, we need to determine whether the meme contains any cyber offensiveness or not. So we also developed the fast code mixed meme data set, which is offensive, which contains offensive and non-offensive kind of memes. Like, in social media, when we write something, we do not write in pure English, because we Indians are multilingual. We speak in multiple languages. So we often switch between languages in social media. So we write some words in Hindi and maybe some words in English. So this is called the code mixing or code switching. So my students have basically developed the fast code mixed meme data set, where some memes are offensive in nature and some memes are non-offensive. So this way we created the fast benchmark data set for offensive detection in code mix Indian setting. Other than this, humor detection, where again on the multimodality, like the data from the social media and again multimodal. We also worked on the India, so where again we've seen some movies and you need some new movies. So the recommendation system were only relying on the movies. Like each movie was having a description, contextual description. So description, we used to recommend some new movies to the user. But now we are also audios and the audio signals and the disconnected. Am I audible now?
Yes,
Ma'am,
ma'am,
you are
audible.
audible, but
Audible, ma'am?
screen is not shared. Now it's
Yeah,
getting shared.
Yeah. I just got disconnected. Yeah, now is it can you see my screen?
Yes, ma'am.
Yeah, so these are some of the application areas of multimodal information processing in which my students are basically working. And now let me discuss about one such application, which is summarization, where we started working on multimodal summarization since long, like since 2020, like for the last 5 years, we are working on multimodal summarization, and we are one of the one of the first group who started working on multimodal summarization, like so yeah. So let me now discuss about this briefly, like what are the things we developed in our research. So now going is a fundamental approach in NLP. So summarization, we have a set of sentences related, or all the sentences are not relevant. So you need to have a suppose there is a sports event and all the newspapers are reporting the same event. So now you have several news events events, news reports. So can we summarize? Summarization is basically of two types. You can easily understand document. Like originally, suppose in your document there are 1000 sentences. Now carefully, maybe you can extract 100 sentences and you can generate the summary. So extractive means that you simply extract the important 100 sentences and you generate the summary. And the abstractive means that you need to rewrite the entire document. Like you have the original document containing 1000 sentences. You try to understand the meaning of the document and then you try to rewrite the summary in your own words. So how the summarization is evolving? So summarization, see, initially people are working on the single document summarization. Like suppose you are searching with the word Taj Mahal. So if you are searching with the word Taj Mahal, either you have the option of summarizing a single document, but maybe you will get, when you are searching in the Google, you will get multiple documents which describe the word Taj Mahal, or maybe multiple images also, and also multiple video clips or multiple videos which are related to the word Taj Mahal. So this way, if you are only considering a single document for summarization, then this is called the single document summarization. If you are considering multiple documents for summarization, then this is called the multi-document summarization. If you are considering documents plus images plus video, then this is called the multimodal summarization. And nowadays, what happens is that whenever there is a news report, reporter wants to make it more interactive. Like in the like Times of India or any big channel in big news report channel, they, whenever they are writing a report, they also invite the readers to comment on the report. Okay, so they want to make it more interactive. So whenever there is a news report, multiple readers are also posting comments on the news report. So maybe the reader is biased towards towards a particular political party, or maybe reporter has made some mistake while writing the report. So maybe the reader can point to those mistakes in their comments. Okay, so this way the reader's comments are also very much useful. So now when we are generating the summary, can we also consider the reader's comments into account? So this is called the reader's comment aware multimodal summarization. So now there are many challenges, like all the readers' comments are not useful. So you need to categorize the readers' comments into three categories. Some comments are very much related to the report, like maybe whatever the reporter is saying, the readers are also echoing the same thing. So some comments are giving us some additional information which are not available in the report. So those are basically some kind of complementary information. So some readers comment are giving some supplementary information, some are giving complementary information, and some are simply irrelevant. Like maybe some users simply write anything arbitrary in their comments. So we simply have to ignore those comments. So this way, before considering the reader's comments, we need to categorize the reader's comments into three categories: supplementary, complementary, and the random. And then random thing maybe we can ignore. And now one at a time, we can either consider the supplementary comments or we can consider the complementary comments, and then we can generate the summary. So initially, we were developing some deep learning models considering the document and the comments. But later on, as the now we have the large language models in hand, so we have also leveraged the LLMs in generating the summary, because these large language models are already pre-trained on huge amount of corpus, and they are very good in natural language generation and summarization. So basically, why not to leverage the basically these LLMs for generating the summary? So basically that is these are the various tasks that we have done in our research group. So moving forward, so this is the problem statement that we basically proposed in initially. This was our first paper. You can see like in the year 2022. We wrote a survey also on multimodal summarization. So you can refer to our survey of ACM computing survey. This is a very prestigious journal. Impact factor is 28. Now it has an impact factor of 28. That time it was having an impact factor of 14, but now the impact factor has raised to 28. And so basically we formulated this problem as a text, image, video summarization problem. So we have a set of text documents and also set of images and a set of videos, and we have to generate a multimodal summary. So in the summary, we have a text summary, few images as the image summary, and a video as the video summary. Okay, so this is our problem statement. So in the input, we have a set of text documents, a set of images like related to a particular topic. Like topic could be a sports event, or topic could be Taj Mahal, topic could be a particular topic, and these documents, images, and the videos are all related. Now you have to generate a text summary. You have to select carefully few images from the image set as the image summary, and you have to carefully select one video as the video summary. So this is our text, image, video summarization task. So initially we started working on this data set by Zhu et al. The data set was proposed in 2017 Empirical Methods in Natural Language Processing conference. So this data set was very small. There are only 25 topics in a data set. Each topic is having 20 text documents per topic, and each document and per topic there are 3 to 9 images, and per topic there are 3 to 8 videos. And for each topic, there are 3 gold standard summaries. Okay, but in the output there was no multimodal summary. Like in the output, we do not have image summary and the video summary. So what we did is that we asked 3 annotators to annotate to select few images and 1 video to select as the image summary and also video summary. So these annotators, they manually check these text documents and the images and the videos, and they basically selected few images as the image summary and 1 video as the video summary. So initially we proposed the integer linear program, basically this is our initial unsupervised based approach. So we extracted all the sentences from the documents, and we extracted all the images from the image set, and from the video we extracted the transcripts, and we separated the audios and the video frames. Where the video frames are added to the image set, and from the audio we generated the transcripts, and the transcripts are added to the sentences, a set of sentences. So this way we have a text set and we also have an image set. Okay, then we projected them in the same space. So the text set and the image set are projected in the same space. We have a set of text vectors, and we also have a set of image vectors. Okay, now basically our objective is to cluster the set of text vectors and also cluster the set of image vectors. So basically the sentences which are somehow semantically similar are grouped together, and the images which are semantically similar should be grouped together. So some sentences are semantically similar, so those should be grouped together, and some images are also semantically similar, so those should also be grouped together. So how did we do the clustering? So the clustering is done by using a multi-objective optimization based approach. So we optimized multiple objective functions simultaneously. So by using a multi-objective optimization based approach, we cluster the set of sentences, and we also simultaneously cluster the set of images, and we have several different objective functions. So we optimized the compactness and the separation. So compactness by separation in the text modality, and the compactness by separation in the image modality. These are two separate objective functions. And also we want that the text cluster centers and the image cluster centers should be very similar to each other. Okay, so these three objective functions are simultaneously optimized by the search capability of multi-objective optimization. So we use the NSGA2, non-dominant shortening genetic algorithm 2, and by using NSGA2, we simultaneously optimize these three objective functions. So you can see the saliency is computed by the similarity between the cluster center and all the sentences in the cluster, and the redundancy is the basically similarity between two cluster centers. And the cross-modal similarity is the similarity between two cluster centers in the image modality and the text modality. And these are the results. So you can see that somehow we are able to reach 39% Russell score. So Russell score is a metric used popularly in the summarization. So we have the actual summary, and our model is selecting the important sentences. Like it is clustering the sentences, and after forming the clusters, each cluster is having a cluster center. So these cluster centers are selected and they form the summary. Okay, that way we have the opt-in summary and we have the gold standard summary. Okay, so now we can compare the opt-in summary and the gold standard summary. And this Russell score is basically a kind of a comparison. So this is string matching between the opt-in summary and the gold standard summary. So we are getting around 39% match between the opt-in summary and the gold standard summary. How many consecutive words are matching between the opt-in summary and the gold standard summary? So this is around 39%. And our image similarity is also 76%. 76% times we are able to correctly retrieve 76 correct images. So next week, what we did is that maybe, all the images are not important. So we categorize the images into two categories. Like given our text is the central modality, like here you can see this is our text summary. The Russian airliner which crashed in the Sinai desert, killing 2 to 4 people, was downed by a bomb. Analysis of the black box recorders indicates the plane had been carrying 217 passengers, including 17 children and 7 crew members. Families of the passengers have gathered at St. Petersburg Airport as bodies begin to arrive back in Russia. If this is our text summary, we can categorize the images into two categories. The images can be either supplementary or the complementary. So if the images contain the same information which is present in text, then the images call the supplementary enhancement. And if the images contain some information which is not present in the text, then those are called the complementary enhancement. Like here you can see these images contain the same information which is present in the text. So they are called the supplementary enhancement. And here images contain the same information which is not present in the text. So they are called the complementary enhancement. So this way we are categorizing the images into two categories. So basically we are checking the similarity between the text and the image, and if the similarity is less than some threshold, then this is called the supplementary, and if the similarity is greater than some threshold, then this is called the complementary. So then we followed a two-stage approach. In the first stage, we are clustering as usual the text and the images, and in the second stage, we are categorizing the images into two categories, supplementary and the complementary, and then we are taking a parameter from the user. So how many supplementary kind of images they want to have in a solution, because multi-objective optimization will provide us a set of solutions on the parrot optimal front. So each solution will give us a possible way of summarizing the data. So in a solution, we can keep some supplementary type of images and also some complementary type of images. So there is a parameter taken from the user, and accordingly we can select some supplementary kind of images and some complementary kind of images. And then there is a post-processing by which we can select a video. The video which is most similar to the text and the image is selected as the video summary. So we also, all these works were done in the English dataset. Already I discussed about the dataset. So that was the English dataset. So we felt the necessity of developing a dataset in the Indian context. So my students basically developed the large-scale multilingual multimodal summarization dataset in the Indian context. So this dataset contains 20 languages having 1.1 million instances, a large-scale multimodal multilingual summarization dataset. The languages are English, Chinese, Spanish, Russian, French, Ukrainian, Portuguese, Japanese, Tamil, Hindi, Marathi, Gujarati, Bengali, Sinhala, Urdu, Pashto, Indonesian, Telugu, Punjabi, and Nepali. This is one of the largest multilingual summarization dataset and largest summarization dataset for 13 languages. So we collected this data like this, BBC. So basically in the BBC, we have a title, we have a date, we have some images, and also some summaries written by the reporter only. And this is the body of the text. So my students have basically crawled the data from the BBC, and then they created this data set. And then they executed some baselines, like these are the already some existing models which they executed all different languages, and they basically shown the results on this data set. Okay, these are not our proposed model. These are already existing models. Like lead 3 simply selects like initial 3 sentences from the document. You say text rank is a graph-based algorithm by which the important sentences are selected for generating the summary. Centroid is basically doing the clustering and then selecting the centroids. MT5 is a transformer-based approach for selecting the generating the summary. So this way, these are the existing models which are executed on different languages. And for English, multimodal baselines are available. So we executed this BART, Pegasus, T5. These are all multimodal baselines which are basically applied on the English data set, and these are some of the results. So now moving forward, we also, as I mentioned, that nowadays we are working on comment-aware multimodal summarization data set. So let me discuss this, why the comments are important. So here you can see this is a article on some, like this is an article written by a reporter where he has mentioned that 57 people spend Christmas abroad, a cruise ship. So he mentioned this as a cruise ship, but there are many readers' comments, and the reader is mentioning that this is not a cruise ship, this is an oceanographic research vessel. Like reporter has made a mistake. Reporter has mentioned this is a cruise ship, but this is basically an oceanographic research vessel. So when the human writer is generating the summary, human writer is consider the reader's comment, and he has written a Russian research ship, MB academic. So basically, the reader's comment is taken into account in generating the summary. So there was a dataset available, readers comment our multimodal, readers comment our data, this multi-document dataset available. So this dataset was having 45 news topics, and these are topics covered in this dataset. Accidents and natural disasters, attack, new technology, health and safety, endangered resources, investigations and trials. But this dataset was completely unimodal. Only text data was present in this dataset. And so my students have basically made this dataset multimodal. So already I have motivated you why we should consider multimodality, because images always convey us better information. So motivated by this, my students basically search for each topic in the internet, and they collected few images related to the topics covered in the dataset, this RAMDS dataset. And then they collected the delivered images, and they basically added those images to the document. So this way that they made the dataset multimodal. So this is the statistics of the dataset. So for each topic, there are 2 images in the dataset, maximum 69 images, and in an average there are 9 images. So total 528 images are collected. So this way we made the dataset multimodal. And then we proposed a transformer-based approach. So now input is article, comments, and also the images. So there is a visual modality block which is processing the image part, and also there is a transformer block which is processing the article and the comments part. And also we have introduced the discriminator-based loss function, which is checking the similarity between the generated summary and the actual summary. And accordingly, it is giving introducing a loss component. And once the summary is generated, based on the summary, a image is being selected. Okay, so this image is not contributing in generating the text summary, but once the text summary is being generated, the text summary is helping in selecting the appropriate image summary. So basically, these are some results. So you can see that by including the image part, there is an improvement in the RUSE-1 score and also in the RUSEL score. And also these are some of the qualitative results. So you can see that image components are correctly selected mostly. So these are the original images part of the data set, and two of the images are correctly selected, and one image is not correctly selected, but in place of that, this image is selected, which is also correctly reflecting the situation. But in the text part, there are some hallucinations. For example, in the original summary, it is mentioned 20 miles east of downtown, but the summary is being generated is mentioning 25 miles south of downtown. So you can see there are some hallucinations, and this may be because of small amount of data, because there are only 45 topics in the data set, and we are training the model using this only 45 topics. So basically, because of this, maybe there are some hallucinations in the model. So now, as I mentioned, that what we are doing is that we are not considering all the comments as it is. We are first classifying the comments into three categories, like supplementary, complementary, and detached. So supplementary means those comments are giving us the similar information which are present in the text. Complementary means that they are giving some information, additional information, which are not present in the text. And detached means irrelevant set of comments. So we are discarding the detached comments, and then sequentially we are adding these comments one by one with the document, and then we are passing them through LLMs, and we are asking the LLM to generate the summary. So this way we are leveraging the advantage of LLM, and also we are categorizing the comments into three categories. So this is our most recent work, and these are the results. You can see like what is happening when we are considering only supplementary comments, only complementary comments, and also relevant comments. So with the supplementary comments, we are getting the best result. So RUSE-1 score and the results are the best when we are considering the supplementary comments. So so I will stop here. So let me just in this year we have also generated a benchmark data set, because this RAMDS data set was again in English. So there was a need of developing a comment sensitive, multimodal, multilingual Indian corpus for summarization. So my students have also developed a comment aware, multimodal, multilingual Indian corpus. So this is called the Cosmic. So Cosmic introduces a comment sensitive, multimodal, multilingual data set. So there are 4959 article image pairs. There are 24,000 reader comments, and you can see we have covered around so there are 9 Indian languages which we have covered till now. So this is our latest paper in SCL published this year, and we collected the data set from the Daily Mail. Like we scrapped this kind of reports and the comments from the Daily Mail, because in Daily Mail it is again interactive. Readers can put their comments. So, and these are some of the results which are already available in our paper. We have the languages like Hindi, Bengali, Marathi, Gujarati, Malayalam, Odia, Tamil, Telugu, and Kannada. And this is the statistics of our data set. There are these 9 languages and total 4959 articles and 24,000 comments. So these are some of the ablation studies, like we have shown how like images are helping, how only comments are helping, how when you are selecting the relevant comments, whether there is any performance improvement in the summary or not. So I think let me stop here. I have already crossed my time. So yeah, if there is any question, I would love to take. Am I audible?
Yes, madam, you're audible now.
Yeah. Any comment or questions?
Ma'am, good evening, ma'am. Session is very informative, ma'am. I hope
Is there any questions, sir? Any queries from the participant side? Ma'am? Okay. Okay, then shall we conclude, sir? Okay. Thank you very much, ma'am, for your insightful presentation on charting new territories, multimodal information processing in NLP through deep learning and language modeling. And thank you very much again. And I would like to invite the Honorary Secretary of IEI Salem Local Center to propose vote of thanks. Please, ma'am.
Thank you, sir. Our most respected chief guest and keynote speaker, Dr. Sriparna Saha, Madam, Associate Professor, Department of Computer Science and Engineering, Indian Institute of Technology Partner. Our respected Chairman, Dr. K. Thangaraj, sir. Respected committee members from state and local center, Mr. Armugam, sir, Mr. Thiagu, fellow engineers, students from various organizations. Good evening to all. It's my distinct honor and a privilege to deliver vote of thanks for today's enlightening seminar on charting new territories, multimodal information processing in NLP through deep learning and language modeling. This is our 102 special webinar. I'm very happy to propose vote of thanks in this occasion. I would like to extend my deepest gratitude to our esteemed speaker, our guest, Dr. Sriparna Saga, Madam, Associate Professor, Department of Computer Science, IIT Patna. Madam, your insightful presentation on the latest development in deep learning, language models, and multi-modal data processing has provided us with deeper understanding of how artificial intelligence continues to transform natural language processing and human-machine interactions. Your talk has truly broadened our perspectives and inspired participants to explore innovative research direction in this existing field. Thank you so much, Madam. We extend our deepest gratitude to our chairman, Dr. K. Thangaraj, sir, whose vision and guidance were driving force behind our successful events. I extend my sincere thanks to our engineers talk team members for their continuous guidance and support. It's my privilege to thank Engineer N. Armugam, sir, for unwavering support in making this seminar in a successful one. Thank you, sir. I would like to appreciate Mr. Thiagu for sincere effort for arranging this seminar. Once again, thank you all for being part of this wonderful learning experience. Thanks to one and all.